Hi, welcome to Securing Multi-Tier Modern Application Architecture with F5 Distributed Cloud Platform. Today I'm going to share with you how you can leverage on F5 VoltStack Kubernetes platform with web application and API protection capabilities to better enhance and secure your multi-tier application. Here I have a sample application called Bank of Anthos, which I modified it to call Bank of Volterra. It is a demo application developed by Google. It is a 3-tier modern financials application that simulates a banking's payment processing network, allowing users to create artificial bank accounts and complete transactions. This application is written to deploy in Kubernetes cluster. It is a 3-tier application from web tier, app tier, and DB tier. It is written in multiple different application frameworks like at the web tier, you have Pythons with Garnicons as the framework. You have in the app tiers, you have the Pythons, Garnicons, and the Spring Boot applications running Java. And at the DB tier, you have Postgres SQL. Each services of the app tiers will talk to the DB tiers, as well as the web tiers will talk to the app tiers. This is a typical 3 tiers modern applications. This application is currently deployed in F5 VoltStack platform into a multi-tier fashion, which each tier is deployed on its own namespace. This multi-tier application can be deployed into many potential architecture patterns. Typically, there are 2 or more architecture patterns for this type of application. You can either deploy this application into a multi-individual Kubernetes cluster, where each functional tier on its own cluster, segregated with a network firewall. For example, the web tier in a DMZ zone cluster, app tier on its own semi-trusted zone, and DB tier on a separate Kubernetes cluster in a trusted zone. Each tier are segregated with a network or application firewall with intrusion protection system. Each apps will have its own dedicated Kubernetes cluster. However, this model in my opinion is expensive, as you need a dedicated cluster for each application functions, and I believe it goes against the purpose on why Kubernetes was designed. Does it mean if you have 50 apps, you need 50 or more dedicated Kubernetes cluster to host each individual apps? This model may cause a very high total cost of ownership as well as operational complexities. Another variant of this hybrid is hybrid cluster isolations, where you have your web tier namespace, created on the DMZ cluster, and app tier and DB tier deployed in a cluster segregated with different namespaces on a separate internal Kubernetes cluster. DMZ and trusted zone are separated with a firewall. This is potentially a more common architecture construct, which also inherited from the monolithic application world. Although what I've shown only web tier apps in this cluster, in the real world, probably the DMZ cluster will have many other applications which have the similar security classification. For example, infrastructure applications, monitoring tools, non-critical applications, connectors, and etc. Fundamentally, whichever architecture pattern fit your organization, unlikely it will be a dedicated single apps per single Kubernetes cluster. It's probably be a shared cluster that potentially will have many other apps. The other deployment pattern is to deploy all of these 3-tier apps on a single highly available Kubernetes cluster, logically segregated by namespaces. This pattern is not uncommon in my opinion, especially for not so mission critical application or application that don't directly expose to the internet. For the purpose of today's demo, this 3-tier application is deployed in VoltStack, which each tier are deployed on a separate namespace within the same cluster. Obviously, in this pattern, if cluster is compromised, all applications within are compromised. No doubt that physical dedicated cluster isolation, which is the first one, is the most secure architecture constructs compared to the rest. However, these patterns may or may not be realistic in most organizations. In my opinion, security is about risk management and risk appetite. Ultimately, you need to balance security, practicality, cost, operational, and complexity to make wise decisions on your multi-tier application architecture. The objective of this demo is not to discuss those various architecture patterns. The objective in this demo is to demonstrate how you can leverage VoltStack native inbuilt security capabilities to secure your 3-tier application where applications are deployed on the same cluster. If you would like your multi-tier application to be deployed in a distributed cloud pattern, regardless of location, you can consider leveraging on F5 distributed cloud platform, where you can distribute your web tier onto F5 virtual Kubernetes, leveraging on hyperscaler infrastructure such as AWS, Azure or Google, or F5 regional edge, so that your web tier is closer to your customer. Your app tier can be deployed on a separate environment, on-prem or public or private clouds, and your DB tier can be deployed onto on-prem data center. Connectivity on all these Kubernetes clusters are meshed into a private encrypted connection secured with web application API protections and firewall. Please refer to Architect, Deploy, Scale, and Operate Modern Distributed Application with F5 Distributed Cloud Platform or H2.0 video for further details. Kubernetes is a containers orchestration platform. Security is often an afterthought. Kubernetes by itself not a security software, hence you need to apply security practice and control onto Kubernetes. Today, I'm going to share with you how you can leverage VoltStack native security capabilities. In demo number 1, I'm going to demonstrate to you how easy it is to create a strong namespace isolations within VoltStack. These capabilities enable you to create an application micro-segmentations within the same cluster. This will enable you to address security controls required between namespaces or east-west traffic. In demo number 2, I'm going to show you how you can easily apply security for ingress traffic to the web tier. You can apply a web application firewall policies to ensure any north-south traffics are properly filtered, monitored, and blocked for any malicious intent before it hits your application. You can also leverage VoltStack service policy to create a fine-grained layer 7 policy or rate limiting control. In demo number 3, I'm going to show you a simple way you can filter egress traffic from your application port to external network. With VoltStack natively integrated transparent forward proxy and network firewall provides frictionless consumptions and enforcement of security control for outbound access from within Kubernetes cluster. In demo number 4, I'm going to touch on Volterra VoltStack Secret Management. It is natively inbuilt within VoltStack, where it provides a uniform identity for authorization, authentication, and secret management for your workload in a heterogeneous environment with PKI-based identity. And finally, in demo number 5, I'm going to show you how you can centrally manage and monitor VoltStack cluster. Depends on how you perceive service visibility and observability. In my opinion, I believe this is part of security control that any organization should have. You can't protect if you can't see. You can't prevent or mitigate if you don't know what's happening to your apps and where those does it interact with. Hence, visibility and observability are more than just an operational tools. In my opinion, it is a foundational component of a better security control. Please do note that this demo only focuses on security aspect of VoltStack. VoltStack platform is built to ease operational burden for Kubernetes platform owners to secure, operate, and lifecycle Kubernetes cluster at scale. How you handle the day 2 operations of many Kubernetes cluster, how you stitch and provide connectivity and resiliency for multi-cloud, multi-cluster Kubernetes, how you manage and monitor your cluster. F5 distributed cloud platform, VoltStack is designed to address those. Before we get into each individual demo video, let's see how Bank of Volterra applications look like and what happened in a Kubernetes cluster without any security protection. Currently, there are no additional VoltStack security enabled in this cluster. Here's the example of the Bank of Volterra applications currently deployed in VoltStack. So this application simulating a banking application or banking transaction. For example, I can create a user or create a new account in this application. I already created one. Let's say, for example, if I log in the user which I created. Once I log on to the application, this is basically my checking account. I can do a fund deposit. Let's say, for example, I want to deploy deposit into bank Y. Let's say, for example, 900. I can do a deposit, or I can do a send payment to Bob. Let's say 800. So you can see that this is a fully functional payment financials applications. Now let's see what happens. This is, I have a VoltStack currently logged on. Let's say, for example, if I log into the BO web, okay, nice, UE app. So what happens is that I log on to the tree namespace. This is a web namespace which have a front-end application and load gen service. In the app space, the app namespace, we have balance, reader, contact, and etc. And as well as the database. All these three tiers of applications are installed on the same VoltStack. So assuming that someone's managed to get into the application, the front end, because the front end are public facing. So probably the first things that someone who managed to get in, they may look into the environment file. Like, for example, try to understand what in these environments have, or do some reconnaissance or enumerations of the environment. Try to find as much knowledge as possible regarding this environment. For example, this application are being created with the default password recorded in the environment variable, which is a bad idea. But anyway, this is just a demo application. Or maybe I may grab a BOA, anything at BOA. So this tell me that there's an app server. This is an app namespace running on port 8080. Some history, app API address, and etc. Or maybe I can, maybe someone who like to go in to see the etc files, try to understand the environment. Or let's say, for example, if this is a Kubernetes pod that a potential attacker is able to get into, maybe the first thing is that he want to try to see whether can it query the Kubernetes API from here. So if you look into the documentations on accessing the Kubernetes API from a pod, basically you can try to run this few command. If I copy and paste all these things there, alright, so now you can see that I already set up a curl and try to talk to the API. You can see that this is server address. For example, if I'm trying to look for, let's say, for example, query for namespace, let's say API v1 namespaces default. So what I'm doing is I'm trying to query the Kube API for namespaces. Looks like it is forbidden because by default, the default accounts are not running as a cluster role or a privileged role, so that you can't query the Kube API. Or maybe if I want to try another, try to query for a specific namespace, maybe BOA DB ports. Is failed as well. So this is expected because, again, by default, the default tokens that is being created do not have a privilege to query or to list the Kubernetes API. Or maybe the attackers will try to keep the enumerations, or try to reconnaissance to try to understand what's the environment. Or maybe someone's, I don't know, maybe potentially they may want to download some tools. Typically, hackers, they have their own tools. They have their own set of tools that they would like to use. For example, if I get the tools, maybe for example nmap, or let's say wget http aws.foops.com.au nmap. So what I'm doing is I'm downloading a tool that I want to use. Let's say for example U plus X nmap. I can run nmap within the environment. So the nmap tool is currently on the pod, and I can start doing some some reconnaissance into the environment. Or maybe, for example, just assuming that in this environment, I managed to find out there's a namespace called BOA-DB, and by chance I maybe try to do a ping ledger db.boa-db. Of course, there's no ping tools there. So typically, attacker, they may have their own ping tools, or why not? Let's try apt install iputils ping. Apt install iputils ping y. Apt update -y. You see, this basically in this environment, nothing's are being secured. These are all the default, where in fact the pod are able to talk to a public or talk to the internet to grab any packages that they want. There's a good and bad, because typically what happens is that in majority of organization, they need to traverse the proxy before they can do the package update. So in this case, because there's no proxy set up, this pod are able to connect to the internet unrestricted. Let's see if I run again. Yeah, so now I'm installing iputil ping tools so that I can do a ping. For example, if I want to find out the environment. Let's say for example, if I want to ping again the ledger db boa-db, you can see that actually I can access to the database, the ledger db boa-db, which is actually is this one. Or maybe I managed to find out that this is the matter of time. If I manage to find out there's a Postgres database located, so what I can do is that I can run a PSQL. I don't have the PSQL tools here, so what I can do is that apt install PostgreSQL client. Let's install the PSSQL client so that I can use this tool, or what I can do is that I can actually download my own set of tools, which PSQL client as well, without me requiring to run the apt install. When someone's run apt install, there's a good and bad, because typically hackers, they may think that probably this is a non-covert channel, probably this is a authorized channel, so this potentially may eliminate any suspicious activity. For example, if I try to download PSQL on some site that is unknown, typically administrator, when they try to do some audits or maybe the log, monitoring the log, that will trigger some suspicious or alert. But by doing updates from authorized source like Ubuntu source repository, probably that will eliminate any malicious alert or any alerts, trigger any alerts. So now I have a PSQL tools. Okay, so if I try to run PSQL -h, let's say ledger db boa-db user admin, and let's say I want to look for a database called PostgreSDB. So now they ask for password, PSSWORD. Remember that just now when we look into the environment variable, we can see that some of the passwords. So potentially attackers, they may try to guess, or maybe try to brute force the password and see. Let's say for example, if I run some command select, let's say that name from PG database, you can see I can list a database. So what I mean here is that from the web tier, I'm able to access all the way to the DB tier. Let's say quick through the. Alright, so now the other things that potentially I may want to see whether can I get to the app tier or not. If I do a curl HTTP, let's say balance BOA apps, all this for 8080, all this information you got it during the enumeration. Say for example, let's say I run RADY. This is ready scripts. So all these informations you can actually look into the environment file. now. So this is the typical what happened is that as there's a financial gain, a lot of attackers, they are very persistent. They are very persistent on finding out the environment and start to attack. So the key thing here is that in the database tier, that's where all the crown jewel that an attacker wants to get into. Or even though if the attacker not going in via the web front end, they can go in from a different namespace. For example, I have another namespace here called default. Let's say, just assuming that this namespace where you put or you store all your monitoring tools. So from this namespace, I can able to access to, let's say for example, I'm going to do the same thing as well. I'm going to connect to this one. This is not, it is from a different namespace going to a namespace. Like for example, I'm going in from default namespace onto the BOA web front end namespace. Or I don't know whether I have PSQL. Okay, here also have PSQL. So if I try to run the same command on this one, I'm trying to log in from a different namespace as well. You will be able to see that I'm able to log into the same database. So now you can see that currently all these 3-tier applications deploy on the same Kubernetes cluster, where there isn't any security or any enforcement done between the namespace. So in our next video, I'm going to show you how you can secure that, how you can secure and create a micro segmentations between all these namespace, and how you can apply ingress as well as the egress policy, and how you can monitor the activity happenings within the cluster. Please refer to the respective individual demo video on how to apply each VoltStack native security control to secure your multi-tier cloud native application.